This section's on 3.7 implicit derivative. So implicit derivative, we're going to take the derivative y, and next to it, we're going to go ahead and put a dy over a dx next to it. Okay? So there are three purposes of the implicit derivative that we're going to work on today. So one of the purposes is that we're going to take the first derivative implicit. The second reason is we're going to find the slope, and then the third purpose we're also going to find is the second derivative implicit. So I'm going to walk you through for each of these examples right there. So let's go ahead and do the first derivative implicit. So the first derivative implicit says that I'm going to take the derivative of y, wherever there's a y, we're going to put a dy over dx next to it. So derivative of y is going to be the dy over dx. The derivative of x squared is 2x. We're not going to do anything with that one, so we'll leave that one alone. And then we have derivative of sine xy. So remember, this is the chain, there's layers involved. So the derivative of sine is the first part we're going to take. Derivative of sine is cosine. And we're going to go ahead and put the xy inside. Then we're going to take the derivative of the inside, which is the product rule. So the product rule says, again, whenever I take that derivative of that y, we're going to put a dy over dx. So let me show you that part right there. So I copy the u, take the derivative of v. So derivative of v is that dy over dx plus, and then I copy the v, take the derivative of u. Derivative of x is 1, so that's not going to show up right there. Okay? So that was the derivative right there. Now all I need to do is go ahead and combine all my dy over dx's on the same side of the equal sign. So before I do that, I need to distribute this cosine xy into this part of the parentheses, because you can see right there, there's a plus involved. So distribute all of this to the first part, and then distribute it to the second part right there. So this is what it looks like. I brought the x in front right there, the cosine xy, this is right here, and then the dy over dx I just put in the back right here. Okay? Then I took the cosine xy, multiplied to the y, I put the y in front right there. So that kind of separates it right there for us with the plus right there. Okay, now I can do the algebra, which then tells me that I can bring the x dy over dx, all of this right here, over to the other side of the equal sign. So it's positive right here, so I'm going to bring it over by subtracting on both sides. So we subtracted on both sides, so it looks something like this. And I still have the 2x on this side, on the right-hand side, and also this right here, the y cosine xy on the right-hand side. We want to factor out a dy over dx. So when you factor out a dy over dx, I have as a 1 right here, that's a placeholder for this right here, right? You can always check it by distributing it right here to see if you go back to the original equation right there, okay? So I factor out a dy dx, I'm almost there, because all I need to now do is get rid of this, and the only way I'm going to get rid of this is to divide, because right now it's dy over dx times, right, all of this part of the parentheses. So we divide it on both sides, and this right here is your final answer for the first derivative implicit. Okay? Now, the second example is to find the slope. Then we're going to actually take the tangent line and the normal line as well. So, doing the same first derivative implicit rule, we're going to take the x squared, take the derivative of that, so that becomes 2x minus. Now, this right here is a product rule. It's a UV right here. There's two ways to do this. You can consider the negative x right here as the u, and then the y is the v, or you can factor out a negative and leave it out there and give the x as the u and the y as the v when you do the product rule. I'm going to go ahead and leave the negative out, and we'll distribute that later on, okay? So, when I take the derivative, this is the 2x minus, I keep it on the outside, I copy the u, I take the derivative of v. So derivative of y was that dy over dx that we mentioned, plus. And then we go the opposite direction, I copy the v and take the derivative of u. Derivative of x is 1, so that doesn't appear right there. Okay? And then plus y squared right here, derivative of that becomes 2y. Because I took the derivative of y, we're going to have as dy over dx right there. Derivative of 7 is 0 because that's a constant. So now I'm going to go ahead and bring the 2x over on the other side of the equal sign. So we're going to subtract it on both sides of the equal sign. I'm going to distribute this negative into the parentheses so I can drop the parentheses. So if we distribute that, we get negative x dy over dx minus y plus 2y dy over dx equals negative 2x. So I see that this right here, the negative y, should probably be on the other side because all the dy and dx's are on this side of the equal sign. So we're going to bring that y over by adding it to both sides, so that looks something like this. Now we can factor out a dy over dx. We factor it out, we get negative x plus 2y right there, and we're going to divide both sides by this right here to get dy over dx by itself. So this right here actually will give us the slope. So where do we get the numbers for the slope? Well, I have this right here at negative 1, 2. Remember, this is your x right here, this is your y. So we're going to go ahead and substitute this into this equation right here to actually find the number for a slope. So this is what it looks like right here. We're going to substitute all the x's with -1. So basically here, we're going to substitute with -1. This right here, we're going to substitute with the 2 right there, right? And then we're going to calculate that and simplify. We get a slope of 4/5. Okay? So the first part now is to find the tangent line. So using the point slope equation, we're going to find the tangent line. So again, we're going to use these right here and then the slope right there. So we have then is y minus 2, because that's your y right there. 4/5 is the slope right there. And then we have this x minus the -1. I put in parentheses, because that way I can distribute that and combine like terms right there. Now, if you want to stop the video right now, you can stop it and finish it up, because my next step, I'm just going to go ahead and give you the answer. Okay, so if you're back in here, let's see if you got the correct answer. Did you get 4/5x plus 14/5? If you did, good. If not, then go back and check your algebra on this. You probably distributed or combined like terms incorrectly, so go back and check that, please. All right, next one is the normal line. So doing the same thing as the tangent line, the only difference was the slope, right? For the normal line, we want a negative reciprocal on the slope right there. So make sure that's a negative reciprocal. Again, you can stop the video now and finish up the problem for your Algebra 2. If not, I'm just going to go ahead and give you the answer. Okay? So did you get y equals -5/4x plus 3/4? If you did well. If you didn't, go back again, check your Algebra 2. Okay? All right, the next one is the third example, which was the second derivative implicit. So we're going to go ahead and do the first derivative implicit, same rules. We're going to take the derivative of 2x cubed, which is then 6x squared, right? We're going to take the derivative of -3y squared, which gives us -6y, and then dy over dx, right? Because that's the implicit part of it. Derivative of 8 is 0, so this is what it looks like right there. Okay, I'm going to bring the I'm going to bring the 6x squared over on the other side of the equal sign by subtracting it, and we're also going to divide by -6y. I'm going to do it all in one shot right here. Okay, so this is what it looks like right here. Okay, I can cancel out a -6 on both top and bottom right there and simplify that. That gives me y squared over y. So this was first derivative implicit. Now, to get the second derivative implicit, all I'm going to do is go ahead and take a second derivative of this equation right here. So you can see right now this is a quotient. That means I'm going to have to do a uv off of this right here. Okay, so when I do a quotient, I'm going to copy my v because it's divide, right? Take the derivative of u, which is then gives us 2x, minus, and then we do the opposite. We go from the top to x squared, take the derivative of v. Now that's where it's going to introduce to us the dy over dx again, because we took the derivative of y right there. Okay? And then again, it's all over v squared. Now this right here is the calculus part of it, the second derivative implicit. So from here, I'm going to substitute in dy over dx with this right here, the x squared over y right there. We're going to substitute it and look something like this. The rest is Algebra 2 to finish it, so make sure you check your Algebra 2 steps. So first of all, this is multiplication right there, so I'm going to multiply these two together right there. That should give us x to the 4th, right? Because when you multiply, you add exponents right there. Okay, so from here now, I need a common denominator with this right here, because this is 2xy over 1 right here. So the common denominator is y, so we're going to multiply top and bottom of this right here with y, so it looks something like this, y over y right there. Okay? So we're going to make it into one fraction. The y's right here will combine because it's multiplication, so that's going to give us y squared right there. So we're here at y squared. So now I just want to get is one common denominator, or one common fraction right there. So that's going to get us to that divided by y right there. So this right here is y squared, and remember it's y squared over 1. So we can't have fraction over fraction in Algebra 2. So we want to get rid of this right here by multiplying by the reciprocal, and the reciprocal of y squared will be then 1 over y squared. So now I just need to multiply the denominators together, because the numerators will not change right there, and that gives us y cubed right there. Okay? If you can always cancel things out by factoring on the numerator and then cancel that from the denominator, you're welcome to do that. But you cannot cancel things off with this right here, because remember, there's a plus or a minus attached to it, so you cannot get rid of that. Okay? Alright, so that was the three purposes of the implicit derivative. So now let's go ahead and do the classwork for this.